In this video, we're going to walk you through a typical day in our math literacy course at Parkland College. One of the things I want you to notice as you're seeing this clip right now is that many of the students are actually already sort of engaged in working on the day's lesson, or at least reading about the introduction as I'm passing out papers and getting ready to make announcements. Each of our lessons starts with a question 0 that asks students to summarize what they got out of the opening paragraph. Many faculty enjoy discussing question 0 at the beginning of every class, while others wait to see what students write in their reflections about question 0 at the end of each lesson. As you'll see in the clip, what I chose to do with this lesson was tie together what we'd been working on with what we were going to be working on this particular day. I also wanted to point out that the notation used for blood alcohol concentration needed special attention, as that it might be misleading to some students.
Awesome. Okay, so listen up real quick. Make sure we're comfortable with what's going on today. What we've been doing lots and lots of has been dealing with slope, dealing with y-intercept, and interpreting the meaning of those. Today we're going to kind of put all that together and work on building some equations and writing some sentences explaining what those equations mean. So this lesson is about the effects of alcohol. There's some interesting... What's that?
You're gonna buy us alcohol?
I'm not buying you alcohol. No, I'm not. So this lesson sort of puts that in the context of the effects of alcohol, so I ask you to look that over, and we'll get started. One of the things I want to point out to you, just so that everyone's on the right page, when we say an alcohol content is 0.08, right? A blood alcohol content of 0.08, that really means 0.08%. Now, this is slightly dangerous, but this is an example of where the real world doesn't use decimals or percentages in the same way a mathematician might. In other words, if I talk about a decimal form of a number as 0.08, and I want you to write that as a percentage, then you might be inclined to say that's what percent? 8%. We've all been trained to move the decimal point 2 places, right? Very good. In this case, it really is the percentage. So I want to make sure that you understand that so we don't misinterpret what this says. So when you see a blood alcohol content of 0.08, that really means 0.08%. All right? So make sure that is clear as you read these problems. So that's why I wanted to say this part first. So go ahead and get started. I'm going to pass the tablet around to you and have you write your solutions.
So if we write 8%, it's wrong?
Yes. A blood alcohol concentration of 8% you'd be long dead. Okay? Everybody hear that question? Leonardo just asked, so if we write 8% when it says 0.08, does that mean it's wrong? I said, absolutely. When it says 0.08, you need to understand that's 0.08%. And that's significant in terms of what things mean. All right, so just keep that in mind as you start this lesson. We good? Awesome. Go for it.
On first glance, this figure might seem just a little bit strange, but I've actually found it to be the most useful tool available to help people understand what my classroom looks like on a day-to-day basis. A professor from the education department in the University of Illinois came to observe my classroom, and this was the result of that observation. The blue rectangles are the tables in my classroom, with the yellow dots representing the male students and the pink dots representing the female students. And then all of the little turquoise circles represent me at various points throughout the class period. So as you can see, very little of my time is spent at the front of the room, and most of my time is spent moving from table to table. I want to answer 2 more questions before we just let the tape run of about 20 minutes or so of class time to give you a feel for how things work. First, how do we make sure students have the correct answers before leaving? I can tell you that's handled in a variety of ways. If you watch this video, you'll notice me passing around a tablet. That's my tablet PC that I'm actually recording this video on. And what I do when I'm using that is I have students, once I've sort of checked off that they have what I view as a good solution for a particular problem, I'll have them write the solutions on a blank copy of the lecture notes, and then if appropriate or if needed, we'll sometimes project those answers at the front of the room to help students make sure that they're all on the same page. Another thing that I'll do very often is have students go to the boards, the whiteboards around the perimeter of our room, and have them present solutions on the board that way. Just one way or another, I like to make sure the students do have the correct answers to all of the problems from the group portion and the class portion of each lesson before leaving. A third option that I'll do as well is just make my way around from group to group and sort of spot check each group and let them know that they're on the right track that way. So sometimes either we don't have time or it's just not necessary to present solutions on the board. So one of those three methods is usually recommended, and I think used by most instructors here at Parkland. Another question that comes up, and again you'll see wide variance in terms of how it's handled from one class to the next, but how do we end class? Typically in any of my beginning and intermediate algebra courses, it would set my hair on fire if students were getting up and leaving before the last minute of class. I've sort of eased back on that stance in this class, as you'll see if you watch the entire video. Some students get up and are actually finished maybe 10 to 15 minutes before class ends. That certainly doesn't happen every day. It's important to point out that my students we're into the third unit, so they know the expectation. They know that they're not allowed to leave unless they have everything completed, and I've either given them a nod or something along those lines. So I think setting the tone for that early is definitely something that everyone needs to consider. And work out whatever works best for them. Some instructors are not comfortable at all dismissing class in any way early, and they hold tight to we stay in the room from opening bell to ending bell, so to speak. Some instructors are a little bit more comfortable with letting students go once they're completed with their work. So that's something that I think each instructor needs to work out, or each department needs to work out with whatever works best with their policies and their personal preferences. And now I'm just going to let the video run for a little while. I'll probably cut it off after about 20 minutes just to keep production time short on this, but I will also make the entire video available for those that want to see it on the Dropbox, same location.
Is that the legal limit for driving
.08 is the legal limit in Illinois, yeah.
in Illinois?
And in most states now, actually.
Oh, in most states. I was going to say, it depends on what state she's in.
Correct.
Well, we'll use 0.
Just up to here, the board.
Put the phone away, all right?
I'm not on. But actually, I have a question for this though. This is for how many hours after 2 a.m. to that's 24 hours. But how would I write this?
No, and don't read too much into it. How many hours after 2 a.m. is 2 a.m.?
Well, 2 a.m. is 2 a.m. But
So how many hours after 2 a.m. is it?
it's no hours.
None, right.
Yeah.
And so what we want to think about there, the hint, is remember, when you think about the y-intercept, we think about that as the what?
The point where x crosses with y.
Say that again?
Where x and y meet each other.
Not where x and y meet. The y-intercept, we think of that as the what?
Where the line
Crosses the y-axis. Awesome. Okay. So in practical terms, in terms of explaining the y-intercept, what have we been thinking of the y-intercept as?
the point which the line touches y.
Okay, forget graphs for a second. Just the practical meaning of a y-intercept. Like think in terms of context of some of the other problems that we've seen.
Where
Like think about the depreciation problem, for example, where the machine was depreciating.
where the number starts.
The starting value, right? And so with this problem, what we want you to do is think, okay, so this story, as it were, is going to get started at 2 a.m. So we have a starting value for the blood alcohol content. What's it going to start at?
It's going to start at 0.
No. The 0.16. So it's going to start at 0.16, and x equals 0 corresponds to our time of what? Our starting time, which is 2 a.m. So that's where the story starts, is at 2 a.m. We start with a concentration of 0.16, and then what happens from there? It starts decreasing. At what rate?
0.15.
I think we left out a 0 there. 0.015 what? What per hour? What are those units? What are the units for the concentration? When we say it's 0.16, it's 0.16 what? Percent. So it starts at 0.16%, and then it decreases at a rate of 0.015% per hour. That make sense?
Yeah.
And that tells you the story, and based on that, we want you to be able to write the equation. What'd you write? 0.0. Awesome. That's it? That's it? What's the question? I'm going to have this conversation, I think, 4 times.
Number 4,
Yeah.
like I have y equals 0.46 times 24.
All right. So let's keep it in the context of our linear relationships that we've been dealing with. Okay. And the story this tells starts at what time? Sort of. We start at 9 p.m. We're saying that happens, and then the concentration builds up to a maximum of what?
What do you mean a maximum of?
Well, what does the concentration get up to?
Well, at 2 a.m. I guess to 0.16.
All right. So now we're starting the story from the point where it starts to do what? Starts to decrease, right? And so from that moment on is when we're saying it's going to be a linear relationship. And so starting at 2 a.m., the concentration was what? 0.16. And 0.16 what? Percent. Good, right? And so 0.16% at that moment, and then it does what? You said decreases at what rate? 0.015% each hour. And so the reason why that conversation is important about hours is we're starting our time, starting our clock at what? When does it start decreasing? At 2, when it starts decreasing, right? So we're going to start at 2, and that's why we said let x equals 0 correspond to 2 a.m. Right? X is the number of hours after 2 a.m.
So we're trying to
So it's going to be y equals mx plus b.
It will be in that form since it's a linear relationship. That's correct. And what I want you to do is think about it in terms of, like I said, the line tells a story, or the story describes a line, depending which way you want to think about it. And so we said we started at what number? 0.16, and then we decreased by
0.015
0.015 each
hours.
hour.
So it's y equals 0.015 x plus 0.16 or minus 0.16?
So let's think about it. Where does the decrease happen? Does the decrease happen by making the 0.16 negative, or does it happen by making the 0.015 negative?
0.015.
Correct.
So negative 0.015x plus 0.16.
Yes. And another way to do that, a lot of people have been writing that the opposite, the other order, so to speak, meaning starting at 0.116, 0.16, and then subtracting 0.015x
The reason I did that was because
to write it look like mx plus b, and that's fine. And b is the starting value. So if you keep it in mind that way, you can write it either order. That makes sense? Awesome.
thanks about that.
No, we can't use that.
Yeah.
I don't know what anything represents. Like,
Oh,
is this a new
okay, hold
formula we're
on.
making up?
So hold on. No. And hold on, just stop right there. What'd you do this for?
Because you said how many hours after 2 a.m. is 2 a.m.?
Okay, so what you've done is sort of verified that that number really is the, what do you get when you plug in 0 for x in an equation? Well, when you plug in 0 for x in an equation, you get the
Why?
y, what do we call that number? The y-intercept, right?
Okay.
So you just verified that that number really is your b, and y equals mx plus b,
Okay.
right? So in terms of an equation, it's just right here, right? And so what we want you to do, and you're going to see this kind of start to happen often. If x represents what does x represent? Hours after 2 a.m., so that's why you can't fill in these blanks. You just need to write this as a sentence. If x represents the number of hours after 2 a.m., then y equals this. What does y represent?
The blood alcohol content.
You got it.
See, all you have to do is ask me.
You guys argue about these things a lot. Does that make sense? And so that's just sort of a generic format we're going to use often so that you understand, and that's what we're talking about back to explain an equation, explain whatever it is we're dealing with, where you can identify what the input is, what the output is, or what the independent variable is, what the dependent variable is, and show you understand what the question was. Does that make sense?
Yeah.
So that's just basically saying you understand what this equation represents. Good? Yes. Awesome.
Did I do
Good
it
job.
right?
That's fantastic.
Okay, cool.
Explain that to me. Explain it. Why-
His blood alcohol concentration peaks at 2 a.m. So you have to, after that, they stop drinking. I'm assuming they stop drinking, and you have to subtract 0.015 times the number of hours from that to go down.
Fantastic.
Okay.
So it's like thinking in terms of our lines, y equals mx plus b, right? That b, in all the contexts that we've looked at, that b, the y-intercept, we think of it in practical terms as the what? Think about the base or the starting value, right?
Right, the starting value.
So with the depreciation, or whether it was the value of a car or whatever it was we were talking about, it starts at this number. That corresponds to x equals 0, so there's your y-intercept. And then the change either adds to or subtracts from that starting number. And so what's happening here, it's the concentration at 2 a.m. starts at 0.16, and then each hour that goes by, it does what?
It goes down.
And that's why you put subtract instead of add. That makes sense?
Yeah.
No? So concentration starts at 0.16,
0.16.
right? And then from that moment, it's doing what? Decreasing at what rate? Explain to me how it's decreasing. It's decreasing by what?
0.015x, right?
Per hour.
So 0.015, that's percent each hour after that time, right? So that's why multiplying that by x, where x is the number of hours, helps your units to make sense, because that's percent per hour times hours will give you what for units?
Times this.
So if you take percent per hour multiplied by a number of hours, what will that give you for units? Here, let's write it down. Remember our unit analysis, right? If we have percent per hour times hours. These are just our units. Don't worry about the numbers. What do you have left?
You have percent left.
Just percent.
Oh, so it's
And
like
so,
the
so,
conversion.
so it is a conversion, exactly. And so that's why we're going to multiply that 0.015 times x, where x is the number of hours. Because that's a percent per hour times x hours. Right?
So this m becomes 0.0.
And is it an increase or a decrease?
Decrease.
So does it need to be
this
positive or negative?
Negative.
Negative there. And then what's the starting value?
The starting value is 0.6.
Correct.
You say correct?
Yep, you got it.
Okay.
That good?
This doesn't necessarily subtract, so do we need the parentheses on this?
So think about order of operations. Do the parentheses do anything? If I took them away, what would you still do first? Would you multiply or subtract first?
Multiply first.
So then those parentheses don't change anything about the order,
Okay.
right?
So I was going by the, multiplying them minus by,
You're thinking of the distributive property?
Yeah.
Now, that only happens if there's a what in between the two pieces in the parentheses.
oh yeah.
What would it be?
A addition, subtraction.
Addition or subtraction, not for multiplication.
Not for multiplication.
Right.
Ah, okay, so
Right.
that's what I was wondering about. Okay.
Yeah.
This problem, if I just try to add this and bring it over here, I don't think I can do that because simple fact that
No,
it's,
you don't want to add it. That is your equation, right?
so just leave it alone.
That's your equation that represents, what does y represent?
Y represents the slope. No, way off.
I'll give you a hint. What does this represent?
The base.
Starting value, but what are the units here? That's what we just talked about.
Starting value, let's see. No, not sure.
Did you get that part?
What does that 0.16 represent?
The starting,
The starting point of what?
the rate.
That's just a note.
What are the units on this? 0.16 what?
So,
What does this even talk? That's percent, right? And then we had the conversation here about this piece, that this is percent per hour times hours, so this is also percent. So this is percent and percent that you're adding together.
0.16
So they're like
minus.
So they're like terms. So what does y stand for?
Percent.
Percent. So y is telling you the percent of the blood alcohol concentration, and x is telling you the
Do it
what?
that way because
How it's going down.
maybe.
But what does x stand for? What units are x?
Number of hours. X is the number of hours, right?
X is the number of hours.
Number of hours.
More specific than that, x is the number of hours what?
That the case is going down, the blood alcohol concentration.
But the number of hours what?
Oh, after 2 a.m.
After 2 a.m., because
Yeah, the
that's
number
when we
of hours
started
after
this
2
story, right?
Right. So numbers of hours after 2 a.m.
So if I get x equals 3, what does that mean?
Nothing. X equals 3. Well, that would be 3 hours after 2 a.m.
So what does x equals 3 correspond to or describe?
It describes the hours after 2 a.m. How many of the hours?
You're saying it right. Just think about what you're saying.
The hours after 2 a.m. that the blood alcohol is decreasing. Is that what you're
Okay.
asking?
But so specifically, when is x equals 3 talking about?
Oh, 2, 5,
5 in the morning.
5 a.m., right?
That's talking about what's going on at 5 o'clock in the morning,
Oh, okay.
right?
Yeah, but not, oh, I see, not the number of hours, but what the hour would be? Is that what you're asking? Like-
Well, I guess I'm trying to make sure we understand that if you have x equals 3, that's not talking about 3 o'clock in the morning. That's talking about 3 hours
Right.
after 2 o'clock in the morning, because that's when
Right.
we started this problem,
Oh, okay, yes,
right?
right. I gotcha. Thank you. What do you bring us today?
You guys got to do questions 1, 2, and 3. How we doing?
Good.
So I want to make sure we understand question 5. Yeah, you guys are doing the same thing. I don't want you to fill in those blanks. I want you to write a sentence that looks like that. So I want you to write a sentence that says, if X represents what does X represent? X represents what? Hours, more specific than that. Hours after 2 a.m. So if X represents the hours after 2 a.m., you won't be able to fit that in there. That's what I'm saying. You have to write a sentence. That's why it says just make it look like this. Don't actually try to fit it in there because you won't be able to. So if X represents the hours after 2 a.m., then Y equals, fill out the equation for Y. What does Y equal? I think if you did it that way, you got to have a negative, right? You're negative. So then Y equals blah 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 represents what? What does Y represent? The blood alcohol concentration as what units would be on it? As a percent. Does that make sense?
Y equals negative 0.015x.
Plus 0.16. Does that make sense? You guys got that?
Yeah. Like easiness, like blah blah blah, and then
However,
you
reading
have
it, I'm
a
like,
maybe,
okay.
and
I
then
can't
you
decide
have
whether
like
I
a
should do my
red
cursive
circle.
reference. I think my cursive would be better.
Let me see what you guys have for number 5. Okay, let's look at this one. Okay? So this one is something that we're going to ask often, and you're going to see lots of these on the exam. And really what this question is getting at is I want to make sure you understand what the equation means that you've written down. Okay? So don't try to fill in those blanks. If you read it, it says write a sentence that looks like that. Okay? So it says if X represents what? We've said all of these things. X represents hours, more specific than that, hours after 2 a.m. So write that down. If X represents the number of hours after 2 a.m., so if X represents the number of hours after 2 a.m., then Y equals what? What's your equation?
0.16 minus the...
So write that down. Then Y equals this. Then that equation represents what?
represents...
Sandra, I said you're not going to be able to fill in those blanks. I said just write it out. You're going to have to write a sentence.
yeah.
You're not going to have room to scribble it in there.
Yeah, I'm just...
Then Y equals our 0.16 minus the 0.015x represents what? What does Y represent? The percent of what? What are we talking about here?
Blood alcohol.
Of blood alcohol concentration.
So it represents the percent of BAC? Is that what you're
Yep.
saying?
Percent of BAC. That's perfect.
Okay, got it.
Does that make sense? So that's showing that you understand what the pieces of your equation mean. Is that good? That's an important thing. As you write an equation, we make sure you understand what it means, what the story tells you, what the variables represent. And in a sentence structure that makes sense. You got it. We good?
Yeah, you don't see 0.16.
The whole equation. The y equals 0.16 minus 0.015x.
Okay.
Yeah.
And that represents the percent.
And that represents the percent of blood alcohol concentration.
Okay, I got it.
Good? And you should be able to do that with every equation you write. We sort of said those things, now we're formalizing them. Good?
Thank you.
Yeah. I want to see your question 5.
Question 5.
So if x represents what?
Hours after 2 a.m.
Hours after 2 a.m., then y equals the equation represents the blood alcohol concentration. Awesome. Good job. That is an important one. We want to make sure that you can explain what your input and output represent and what the units are for the variables in your equation. Does that make sense? Those questions will be all over the exam. And they're pretty simple if you train yourself to think clearly about what does X stand for, what does Y stand for, and as you think about those things, then your equations will even make more sense. Good? You say you had a question?
Yeah, number 10, we're stuck.
Let me see. So number 10, we're still working on this equation. So at 4a, so I'm just checking number 9, so we're good here. 2 is okay. So now how many hours would it take to drop to 0.08? So there are a couple of ways you can do it, but I think the simplest way is to use your equation. And I think maybe what we talked about with question 5 might even help you in terms of understanding what to do over here.
Would you equal it, like the y be the 0.08?
Why would you do that?
Because that's what you want to get to.
What does y stand for?
Yeah, it's the
No, not hours.
Blood, yeah.
So would it make sense that you could put 0.018 in for y?
Yeah.
Because 0.08 is the blood alcohol concentration, right? And so if you put that in for y, then what would it allow you to do?
Subtract the 0.16.